Hi everyone, welcome to the webinar. We're just going to wait a couple more minutes to allow a few more people to join in, so stay tuned. Everyone, welcome. We're just waiting one more minute to allow a few more people to join, and then we'll get started. Everyone, welcome. Just a few more seconds, and then we're going to get started. Hey everyone, so I think we have enough people, so we're going to get started. Welcome to the webinar on AI in cybersecurity, how elevating DNS security and threat detection can serve your overall network security strategy. Together with me, I have Dennis. Dennis is our account executive in Canada. But before we get started and I let Dennis introduce himself, just a few housekeeping items. So just so you're aware, the webinar is recorded and we're going to share the recording and the slides with you at the end in a few days. You're going to have a small survey popping up at the end. If you can get us top ratings, that would be amazing, of course. And with that, I leave the floor to you, Dennis, to introduce yourself and to get started.
Excellent. Thank you, Emily, and very nice to meet everyone virtually. And I'm pleased to speak to you about AI and how our DNS solution helps enterprises. Okay, let's get right at it. My name is Dennis, and I've been in the DDI industry for the past 25 plus years, 10 with EfficientIP. I've had several roles with EfficientIP, including solution architect and today account executive. For today's session, I'm going to discuss how artificial intelligence is used to detect domain-generated algorithms. We'll start with a quick overview of what domain-generated algorithms are, or better known as DGAs. We'll discuss common DGA detection methods. We'll look at some new approaches for DGA detection, how EfficientIP's innovative machine learning algorithms accelerates DGA detection, and finally, the value of EfficientIP's AI-driven DNS security solution. But before we get started, quick reminder who EfficientIP is. EfficientIP is a global leader in core network services, specializing in DNS, DHCP, and IP address management, better known as DDI. We also complement DDI with network automation and security. We empower digital transformation by helping organizations modernize infrastructure to meet today's IT and security challenges. EfficientIP has a worldwide reach, headquartered in Paris, and operate in over 110 countries. But let me tell you what's really important about EfficientIP. First, EfficientIP has been recognized as the market leader and outperformer in the 2024 GigaOM Radar Report for DDI. For the second year in a row, I might add. The GigaOM Radar Report awarded us as top innovator, ranking us closest to the center to the center of the radar, highlighting EfficientIP's most advanced DDI solution, or us as the most advanced DDI solution on the market. GigaOM is a trusted advisor by decision makers. The GigaOM Radar Report helps IT leaders leverage vendors based on core capabilities, innovation, and business impact. EfficientIP has a proven commitment, and this recognition underscores ongoing focus that delivers cutting-edge reliability of our solution in the DDI space. To request a copy of the GigaOM report, please visit our website at efficientip.com. Okay, so the question of the day, what is a domain-generated algorithm? A domain-generated algorithm, or DGA, is a technique used by cyber criminals to generate a large number of domain names in an automated fashion. These domains are often used by malware to communicate with command and control servers, which essentially is for communicating or coordinating attacks, sending instructions, and receiving data from compromised systems. Here's a diagram illustrating how DGAs are used by attackers to maintain communications. The attacker generates a large number of domains using the algorithm. The malware queries these domains to send information back to the attacker. The attacker then generates additional domains to send commands to the malware. By frequently switching domains, attackers evade detection and ensure uninterrupted communication for the malware operation. Let's take a look at probably the most infamous DGA-related cyber attack, Conflictor. It was first discovered back in 2008, and it infected over 9 million devices, forming a massive botnet. It exploited weak passwords and used DGAs to evade detection by generating 50,000 domains daily at its peak. It disrupted IT operations globally, and thousands of devices remain infected even today. Another example is Sunburst, a 2020 supply chain targeting SolarWinds Orion. It leveraged DGAs to generate randomized subdomains to evade command and control communication. Sunburst compromised over 18,000 organizations, including U.S. government agencies, military, and global corporations, leading to widespread data exfiltration, espionage, and long-term impact of critical systems. The attack continues to disrupt networks even years after it was first discovered. Here's a snapshot of well-known malware families that use DGAs. These are real-world cases documented in the MITRE attack, which tracks how attackers operate based on observed behavior. You'll recognize Conflictor from a previous slide as an early large-scale infection. Then we have more modern threats like Doki, which use blockchain to generate domains, making it even harder to detect and block. Look, the key takeaway is that attackers are constantly evolving their tactics to stay ahead of traditional security tools. You have to understand how these malware families behave to essentially build stronger detection and defense strategies. Now, we'll review some common DGA detection methods. This might get a little techie and some folks might have their eyes glaze over, so strap yourself in and hang on. Let's talk about how most traditional solutions try to spot DGAs. Spoiler alert, it's kind of like a grammar police for domain names. Most existing solutions for DGA detection rely on syntax-based analysis. Basically, they're looking for the style of the domain, not the substance. This method focuses on statistical characteristics like domain names, like randomization, length, or character patterns. It's kind of like catching a criminal because their fake name looks suspicious, but then the attackers get clever with how they generate domains, and quickly these approaches fall short. Some vendors have turned to machine learning and even deep learning to improve DGA detection, but attackers have adapted. new DGAs are now being designed specifically to evade these detection methods. This arms race is highlighted by how challenging DGA detection has become and why we need a more advanced, adaptive solution to keep up. We're going to get really techie here, so hang on. Here are the key challenges of syntax-based driven detection. First, they struggle with highly randomized domains, which overwhelm pattern-based detection systems. You can see in the CyberLocker example that it generated random domains with flat character distribution, making it very difficult to detect. They also fall short detecting domains that mimic legitimate patterns as they blend seamlessly into normal traffic. This is an example that you see in the SOPO box creates domains resembling Alexa's top 1 million requested sites, making them appear legitimate by bypassing detection. These common methods have high risk of false positive, as syntax-based methods often misclassify legitimate domains as unusual patterns or malicious. That reduces accuracy and reliability. Finally, this method is easily bypassed by advanced DGAs, which adapt to strategies to exploit weaknesses in static syntax-based approaches, as we've seen in these examples. So it's clear, we need a new approach. Before we dive into detection of DGAs, there are 3 things we know on how DGAs behave. First, most DGAs are not registered, as registering domains are costly, and only a small part of the domains are actively used to perform attacks. Second, only infected clients query these domains because they run the same DGA, resulting in identical queries. And last, over time, as malware and botnets spread within the enterprise network, a number of infected clients querying these domains progressively increase, reflecting the expanded impact of the infection. With these 3 facts in mind, EfficientIP has introduced a new approach for DGA detection, leveraging artificial intelligence, or AI. The objective is to identify clients that have queried domains generated by DGAs. Over a period, most infected clients query nearly all the DGAs generated. However, the challenge lies in searching for approximate matches within immense volumes of data. This method accommodates incomplete information as well, ensuring that factors such as offline clients or missed DNS packets don't compromise the accuracy of the analysis. The confirmation of association between domains generated by DGAs and clients can be established using a combinational technique, such as a matrix reorganization. Simply put, in a matrix where domains are represented by columns and clients by rows, columns and rows are rearranged to aggregate the association. This allows the the identification of clusters, which represents the DGAs. Within this algorithm, it's quite impressive. It is also highly sensitive to noise, meaning legitimate DNS traffic from clients can interfere with the analysis and render it ineffective. So what do? Simple. We use tuple clustering. All right, not so simple. So let me explain what a tuple cluster is. A tuple cluster is a technique used by cybersecurity, especially for DGA detection. It groups and analyzes domain names based on patterns in how it's used rather than just what it looks like. At the core, a tuple cluster groups domains based on network metadata instead of just domain name syntax. A tuple is just a set of data points, typically things like source IP address, destination IP address, query timestamp, DNS response time, and frequency or time of request. The diagram here shows a cluster or clusters that are color coded by our algorithm. They correspond well to DGAs. All clusters, except for that green one, can be connected to a specific malware. The green cluster, however, at a point in time, showed only low indication of a DGA, but not quite an attack. However, 6 months later, we were able to link it to a well-known malware. Thanks to this model, users were already protected even before the malware was fully identified. This technique is similar to unsupervised or semi-supervised machine learning for clustering. This example allows us to detect weaker signals faster than other machine learning-based models, meaning we can identify malwares using DGAs with considerably fewer clients involved. Now, let's see how this innovative technology can help. Patented tuple clustering technology is integrated into our AI-driven cloud detection engine. By leveraging global scale data collection and deep client behavior insight, it identifies and monitors DGAs. Detected DGAs are blocked and added to the DNS threat feed, enabling proactive protection at its earliest stages. The power of this advanced technology lies in its ability to detect threats early, before traditional security tools even notice them. In this example, you'll notice at a recent detection of a DGA that certainly bypassed conventional security solutions. These screenshots were taken directly from a live EfficientIP DNS Intelligence Center environment, showcasing real-time visibility and early detection that would have otherwise been missed. And this dashboard highlights 30 days of DGA detection activity, showing both the volume of threats identified and confirmed matches within live traffic. Each match represents real attempts by users or devices to reach malicious domains, requests that were successfully blocked thanks to proactive early detection. Not just visibility, this is real-time protection in action. DNS-centric threat intelligence is a critical component for effective DNS filtering. By collecting and analyzing massive amounts of global DNS traffic in real time and creating feeds from trusted sources and using AI, EfficientIP generates a comprehensive, accurate, up-to-date feed of malicious domains. This feed is categorized into threats such as phishing, malware, spam, and of course DGAs. This feed is then utilized in two formats: response policy zone, RPZ, for standard DNS firewalling, and EfficientIP's DNS Guardian client query filtering for advanced DNS filtering. These formats allow organizations to block, filter, or report malicious queries at the DNS level, ensuring harmful domains are neutralized before they pose a threat. Now, let's take a look at how these advanced DNS filtering engines are integrated into our automated protection. EfficientIP's DNS solution accelerates incident response with smart, adaptive countermeasures and deep DNS intelligence. These built-in protections like IP quarantine, rescue mode, rate limiting, traffic redirection respond automatically to threats, reduce any manual work, and ensure uninterrupted DNS service during attacks. To support investigations, these DNS insights provide centralized visibility into global DNS traffic, powered by advanced analytics, including domain intelligence, risk scoring, and historical data. This enables security teams and SOCs to detect and investigate anomalies faster, accurately assess threat levels in real time, and make confident decisions with fewer false positives. By leveraging these capabilities alongside EfficientIP's DNS Intelligence Center threat investigation, you'll gain faster decision-making, accurate threat response, and uninterrupted DNS service, even in the face of an active attack. To close this out, let's bring it back to what really matters: how EfficientIP DNS security solution delivers real-world value. No cliffhangers, just smarter, faster, more resilient DNS. Our solution enables security teams, SecOps and SOCs, to manage DNS attacks throughout the life cycle, ensuring data protection and service continuity and operational efficiency. First, it protects with built-in security, dynamic threat blocking, and DNS-focused intelligence. Next, it detects real-time threats like zero-day phishing, data exfiltration using our AI-powered technology. And finally, it responds with active countermeasures, actionable DNS insights, and automatic threat remediation. EfficientIP security solution is built for resilience, speed, and control, empowering organizations to protect, maintain service uptime, and streamline operation. Here's how we deliver measurable impacts. EfficientIP delivers smarter, faster threat detection by leveraging advanced AI-driven analytics to uncover even the most evasive DNS attacks in real time. These threats are neutralized instantly through patented adaptive countermeasures like IP quarantine and rescue mode, seamlessly integrated into your existing security ecosystem. Your overall security posture is strengthened to protect that's extended across users, applications, data, and infrastructure against internal and external DNS threats. Service continuity is ensured through intelligent DNS layer protection that minimizes disruption and enables rapid recovery during attacks or disasters. Operational efficiency is increased by automating threat detection response and significantly reducing workload for security teams. And of course, risk management and compliances are important, with robust monitoring, analytics, and reporting that supports cyber resilience and regulatory compliance. EfficientIP helps you take control of your DNS infrastructure, enabling faster detection, stronger defense, and more resilient networks. Last slide to bring it home. EfficientIP's 360-degree DNS security solution provides end-to-end protection for DNS infrastructure across every phase of the threat lifecycle. It combines proactive defense, intelligence detection, automated response to ensure data protection and service continuity, and of course, operational efficiency across both public and private DNS environments. The 360 model illustrates how these capabilities work together within the product suite. Solid Server DNS forms the foundation with built-in security features like intelligent RPZ filtering and policy-based threat blocking. DNS Threat Pulse delivers real-time AI-driven threat intelligence, analyzing and categorizing malicious domains at internet scale. DNS Intelligence Center enables deep investigation, correlating live DNS traffic with threat intelligence to uncover risky domains, behaviors, and historical patterns. And DNS Guarding adds advanced protection through patented technologies like DNS transaction inspection, client filtering, and adaptive countermeasure, stopping threats dynamically as they evolve. And the granddaddy DNS Blast, ensuring maximum resilience and performance, even during large-scale or complex DNS-based attacks. Together, these components form a comprehensive, adaptive, and resilient DNS security architecture designed to help you stay ahead of evolving threats while simplifying operations. Emily, I'll turn it back to you if there's any questions from anybody.
Thank you, Dennis, and thank you for the presentation. So as a reminder, everyone, you can ask your questions in the control panel from your GoToWebinar console or on the web app. for now, we don't have any questions at this time, so I'm just going to wait a few more seconds to see if anything pops in. Of course, if you don't want to ask your question now, or if you want to ask your question later, we will send out the recording and the slides with Dennis's contact details, so you can reach out directly to him to ask your questions. Cool. I don't see any questions coming in, so we're just going to close the session. Thank you everyone for attending. We hope you find the session very insightful, and we'll be in touch. Thank you everyone. Bye.
Bye-bye.